Hello and welcome to Lesson 7.3. Today we're going to look at solving systems using eliminations and the Part 2 video. In the Part 1 video, when we were solving using elimination, everything always seemed to work out pretty nice. And by that I mean we usually had two equations that either on the x or the y, we had the same coefficients and they were either opposite signs or they were the same coefficient with the same sign and we just had to multiply one equation by -1. So those worked out really nice. Now today, things are going to be one step trickier, okay? And by that I mean, what we're going to look at here is, notice between these two equations, I have a 2x and a 10x, and I have a 5y and a 3y. So in order to get my equations so that I have the same coefficient but with opposite signs, I'm going to have to multiply one of my equations by a numerical value that's going to give me the same coefficient. So when I look between my x's and y's, I think the x's are going to be the easiest. So if I multiply this first equation by a -5, that's going to give me a -10x on the top and a +10x on the bottom. So the reason I want to do that is because that will eliminate my x and allow me to solve for 5. Now when I do this, please rewrite your equations, both the top and the bottom one. So this is going to give me -10x, -5 times a +5 will give me a -25y, and then -5 times a -22 will give me a +110. Then I'm just going to rewrite this 10x plus 3y equals 22. And now I can go ahead and add my two equations. And when I do this, I see that my x's are going to cancel. And I have -23y plus 3y, which will give me a -22y. And 110 plus 22 is going to give me 132. Now when I go ahead and I solve for y and I divide both sides by a -22, I end up with y being equal to a -6. So again, these are coordinate points for solutions, so my y value is a -6. Now I need to go and solve for my x, and I'm going to do that, if you recall, by going and taking this y value and plugging it into either one of those equations, and it doesn't matter, but I'm going to use the bottom equation here. So I have 10x plus 3 times a -6 equals 22. Well, this is going to give me 10x minus 18 equals 22. So I'll add 18 to both sides. And I have 10x is going to give me 40, or x is going to give me 4. So now the point in which these two equations are going to intersect is the coordinate point for -6. For our next example, we have 3x plus 6y equals a -6. And I have a -5x minus 2y equals a -14. So when I see that I don't have any common coefficients, what I do is I look to see, can I multiply one equation and make it turn into the other coefficient. So in this case, if I do that, I can't make the y's or the x's go easily, but I can make the y's go easily. And I notice right away, if I multiply my bottom equation by 3, that's going to give me a -6y on the bottom and a +6y on the top. So I'm going to rewrite both of these, and I have 3x plus 6y equals a -6, and I have a -15x minus 6y equals a -42. So now I'm going to go ahead and add these equations up. And I have 3x plus a -15x, which is going to give me a -12x. My y's will cancel, and -6 plus a -42 will give me a -48. When I divide both sides by -12, I'm left then with x equals a +4. And I can go ahead and start writing my coordinate point. Again, I'm going to plug this in to one of my equations. So I'll just plug it in here to the bottom one, and I have -5 times 4 minus 2y equals a -14. So this gives me negative 20 minus 2y equals negative 14. I'm going to add 20 to both sides, and I have negative 2y equals a positive 6, or y equals a negative 3. So my coordinate point then, for my point of intersection, is going to be the coordinate point for negative 3. Now for example 6, we're going to take this one step farther, and I have 4x plus 2y equals 14, and 7x minus 3y equals a negative 8. Now here, there's not going to be something that I can multiply 4 or 7 by to get it to the other number. Likewise, I can't multiply 2 by 3 or 3 by 2 to get me to one of the others. So at this point in time, what I'm going to do is I'm going to look and see what I can multiply both equations by to get a common number. So if I were to sit there and give you my thoughts out loud, I notice that my y values have a positive and a negative to where my x's are both positive. So I'm probably going to choose to eliminate my y values because I already have the positive and negative taken into account for. So I need to get both of these y values to the same number. So if I multiply my top equation by 3 and my bottom equation by 2, this is going to give me 12x plus 6y equals 42, and my bottom equation is going to give me 14x minus 6y equals a negative 16. Now what I've done is I've given myself the same coefficient with opposite signs on the y value. So now I'm going to go ahead and I'm going to add these up like we've been doing all along. And I have 12 plus 14 will give me 26x. My y's are going to cancel. And 42 minus 16 then is going to give me 26. So x then is going to equal 1. Now I'm going to follow the same process I've been doing all along. I'm going to take my 1, plug it in for one of my x's. So I have 7 times 1 minus 3y equals a negative 8. So that gives me 7 minus 3y equals negative 8. If I subtract 7 from both sides, I have negative 3y equals a negative 15. Divide both sides by a negative 3, and I see that y is equal to a positive 5. So I plug that into my coordinate point, and now I've solved my system. For my last example, I have 3x plus 5y equals 10, and I have 5x plus 7y equals 10. Now here, both x's have positive coefficients. Both y's have positive coefficients. They're both different numbers, so I'm going to have to multiply both equations by something to make the x's the same or the y's the same, and I'm going to have to make one of them negative. So for me, I'm just going to go ahead and try to cancel out the x's because I'll have smaller numbers, but it really doesn't matter which route you go. So if I multiply my top equation by a positive 5 and my bottom equation by a negative 3, this is going to give me 15x plus 25y equals 50. And negative 3 times 5 is a negative 15x minus 21y equals a negative 30. So if I add these together, I'm left with a positive 4y equals 20. And if I solve for y, y is going to equal 5. Okay, now we're going to take that y value and we're going to plug it into one of our equations. So we'll just go ahead and do it here. And I have 5x plus 7 times 5 equals 10. This gives me 5x plus 35 equals 10. And then I'm going to subtract 35 from both sides. So this will give me 5x equals a negative 25, or x equals a negative 5. So my coordinate point is negative 5, 5. Please let me know if you have any questions, and we will go over those in class tomorrow. Thanks, and have a great day.